today we learned a little bit more about electrical terms, electricity things. As we go into lighting, we need to make sure we understand the volts, the watts, the amps, things like that, in order to properly install lighting. So what's most important when installing lighting in a landscape is to make sure you avoid voltage drop. And how to calculate that is there's this formula here. It's called the it's just called the voltage drop formula. Okay, so to show the formula, I'm going to be using a whiteboard. It's a little easier to draw it out while talking. So we're going to start with, the voltage drop formula for lighting circuits begins with the length of the wire. So total length, you can do the total length from the transformer to each light fixture, but it's best to do from, so if you have the transformer here, okay, and you have like a string of lights, and let's say you have a branch off here, it's a little shorter, okay, let's say there's a light here and a light here. Okay, you would want to calculate the length from the transformer to the farthest point. Let's say this is shorter, actually. Okay, because even if the voltage drop might be different to here compared to here, but as long as from the furthest point, the voltage drop is still good, like it's within the parameters for LED lights or halogen lights or whatever you're using, then it should be good for the rest of the circuit. So you get the total length, and you just do feet for that, and then you multiply that by the watts, and that's the total watts used in the circuit. So that's including every light fixture, for that line. Now, if you had a separate line going off with other light fixtures, you wouldn't include that one. You would do its own formula, but for this one, you would do a formula with the total watts used. And then you'd multiply that by 2. And the reason for that is because there's a wire running out and there's a wire coming back. There's usually 2 wires. So you want to make sure you factor for both, for both running and coming back. And then you divide that by the KCs. And the KCs is a factor predetermined by smarter people. And it's pretty much, depending on the gauge of the wire, how much volts drop naturally. It's just a unit used. And I'm going to write here for a 12 gauge AWG, that number is 7,500. For 10 gauge, it is 11,920. And for 8 gauge, sorry if you can't read my handwriting, is 18,960. So with each gauge of wire, the voltage drop is different because of the thickness of the wire. The way the electricity moves throughout it can cause the electricity to drop more or less. So for example, if the length of the wire, let's just say it's 75 feet. Let's say we're using LED lights and the parameter is 10.5 to 15 watts or volts. Yeah. So let's just say the length is, sorry, I'm gonna just do it right here. The length is 75 feet total times, let's say there's let's say there's 10 fixtures on there and they're each at, since they're LED, they're each at 3 watts. Okay, so that's 30 times 2, and we're using a 12 gauge, so 7,500. And let me just get a calculator really quick. So you'd get 75 times 30 times 2. You divide that by 500. And that equals 0.6. So what that means is that the voltage drop is 0.6 volts. So if the transformer is giving off 15 volts, pretty much at this farthest light fixture, because that's where we calculated from, and assuming there's, 10 fixtures or whatever. At this light is actually only getting 14.4 volts instead of 15. So we're still in the clear because that's in the parameters of the LED light functioning. And along the way, the voltage drop might vary depending on the light fixture and the distance from the transformer, but we know that at the furthest point it's okay, so it's okay for the rest of the fixtures. Some other important things when establishing lighting in a landscape is you need to make proper connections. There's mechanical, so you have to make sure wires are touching the copper to copper. You have to make sure they're waterproof and that they're strain resistant. If you ensure all of these are all the wires are properly connected this way, then the circuit should last longer, and you won't have to go in and fix it as much. There's also the Ohm's law, the basic law of electrical current flow that we learned. And these are just different ways to calculate, like volts is amps times resistance, or amps is calculated by watts divided by volts, and watts are calculated by amps multiplied by volts. So these are just different formulas that you use when installing electrical lighting. And there's machines out there that will help you calculate the watts, the volts, and the amps, and also the resistance. So yeah, these are just some electrical terms used and also formulas for landscape lighting installation. So hopefully I have more for you later in the future. Thank you.